Hello everyone. Today we're going to learn about electrochemistry, which is 10.1 and 10.2. Most of the students very confused in this chapter as it required anode and cathode and blah blah blah. So we're going to learn more about electrochemistry. What are we going to learn today is about the galvanic cell. And next is the simple way how to improve in this chapter. And third, we have to learn about example of question that we provide for you to test your skill in this chapter. Next, the very important things that students have to know is about oxidation and reduction. And oxidation is a process where an atom loses electron. The SRP, which is standard reduction potential, is less positive. It is a reducing agent as it undergoes oxidation, and it is an anode. The new method that we show you is about OHEN. Check out the blue one, which is positive, negative, negative, and positive. The meaning of that is that it adds oxygen, it loses hydrogen, which is negative. The negative sign, it loses electron, and the positive sign is about the number of oxidation is increased. That's about oxidation. And we're going through about the reduction. The reduction is a process where an atom gains electron. The SRP is more positive. It is an oxidizing agent as it undergoes reduction, and it is a cathode. Check out the OHEN. Negative, positive, positive, and negative. It loses oxygen, it gains hydrogen, it gains electron, and the number of oxidation will be decreased. So very simple about oxidation and reduction. And now, show and tell. The most important thing in this chapter is about cell equation. First, we're going to learn about overall cell equation, and next, we're going to learn about cell notation. Okay, let's continue our journey in this video. First of all, we have to know about the half equation in anode and cathode. In anode, there are oxidation process, so it loses electron. Therefore, the electron is right at right side. Next is at cathode. Cathode undergo reduction, so it gain electron. Therefore, the electron must be right at left side. After we find the anode and cathode half equation, second we have to balance the value of electron, and third we have to combine both of the equation. Let's find out the example that I have stated that. There are anode and cathode half equation up there, but the value of electron is not same. So, how are we going to balance it? We multiply the cathode half equation with 2. So, there are 2 electrons at cathode and 2 electrons at anode. That is second step. The third step, we have to combine all the equation. So, the electron must be crossed out, and then we can produce zinc solid, 2 silver ion, and produce zinc ion and 2 silver solid. Okay, we're done with overall cell equation. Now let's proceed about how to write cell notation. The formula that we're going to introduce is about A, B, and C. A for anode, B for bridge, and C for cathode. Look for the example. 2 lines in between of anode and cathode is the salt bridge. You must remember cell notation A, B, C. First is anode, B is for bridge, and then going to be cathode. Then for show and tell. Now we're going to calculate something in this chapter, which is standard cell potential. The formula that we're going to use is kakak tolak adik. Kakak stands for standard cell potential for cathode, and standard cell potential for anode is called adik. E node cathode minus E node anode. Kakak tolak adik. The value of SRP is being given in the question. Let's check out the example. For example is zinc and silver. You must remember that if it is more positive, so it undergo reduction and it at cathode. If it is less positive, it undergo oxidation and it is anode. You must remember to use kakak tolak adik to know the cell potential, standard cell potential. Done with this. And then we're going to go to Z10.2, which is nurse equation. In this subtopic, we're going to learn about this equation, which is students very hate because they don't know how to use this. So I'm going to show you how to use this. The N is stands for number of moving electrons. Let's check out the example first. Given by the question is concentration of zinc ion and concentration of silver ion and the standard potential for galvanic cell. And then based on the equation, overall equation that we do together just now, so let's see what is the answer. Just substitute the number and the concentration of reactant and the product in the equation. N stands for the moving electron. How are we going to know? Just look at the charge at zinc 2+. So that means that 2 moving electrons in this galvanic cell. Just substitute. Standard cell potential is 1.56 and equal to 2. The product based on equation is zinc 2+, 0.5, and the reactant is 1.0. And then you got the answer for cell potential of the galvanic cell. Right, done for 10.2. Now we're going to look for the example that I have stated in front, which is let's challenge yourself by answering this question. This is the question. And this is the answer for number 1, number 2, and number 3. This is number 4. You must state it and you must always jot down the info given to you. It helps you a lot in your calculation. Hey, you did it! Congratulations! Now you know how to solve the problem in that question. You know how to use the formula, which is nurse equation, anode and cathode, and whatsoever like that. So that's very good and you improve a lot. You never know what you can do till you try. Thank you a lot for watching this video, and thank you very much for our chemistry lecturer, Miss Tay, for always supporting us to finish this video. And I hope that we get an ace in our chemistry test and we succeed together in our studies. Bye!